Okay, so we're looking at example 5 here. Stunt pilot flies around in a circle like this. Okay, we've got a radius here of 350 meters. We know that the person is going at a constant speed of 70 meters per second, and we know that the mass is equal to 80 kilograms. Okay, and we're looking at the force on them at the side and at the top and at the bottom. Okay, so let's do the side first. Okay, now at the side of the circle, as the pilot is flying around, okay, they're going to be flying around like this. They're sat in the seat. Okay, so here's the seat, and they're sat. This is the person sat in the seat here. Okay, and we're worried about the force from the bottom of the seat, not from the back of the seat. Okay, so if you think about it, the weight here would apply a force on the back of the seat, but we're not worried about that, only on the bottom of the seat. So the weight here and the centripetal force are perpendicular, so it's the contact force between the person's bottom and the seat that's going to provide the centripetal force, and that's the force that the person is going to feel from the seat. So let's just do part B here first. At the sides of the circle, the force on the person's bottom is going to be equal to the centripetal force. So it's going to be equal to mv squared over r. Okay, so it's going to be equal to 80 times 70 squared over 350. Okay, and if you work that out, I think you get 1,120 newtons. Okay, let's just double check. 80 times 70 squared divided by 350. Yeah, 1,120 newtons. So that's the force on the person's bottom from the seat, because the bottom of the seat provides the centripetal force at the side of the circle, and that'll be the same here as well, obviously. Okay, now let's do A then. Okay, so if you look at A at the top of the circle, we need a centripetal force to be acting, and the centripetal force is going to be equal to mv squared on r. Okay, now what provides that centripetal force? Well, it's two things. It's a combination of mg, the weight of the person acting downwards, and Fn, which we'll call the normal contact force from the seat. Okay, so we know that mv squared over r is equal to the normal contact force plus mg. Okay, because it's the combination of these two forces acting towards the centre of the circle that's providing the centripetal force. So we know that 1,120 is equal to Fn, which is the normal contact force from the bottom of the seat, plus mass times gravity. Now mass times gravity is 80 times 9.81, okay? And if you work that out, 80 times 9.81, you're going to get 784.8. So what we can say here is we can rearrange this equation. Fn is equal to 1,120 minus 784.8 newtons, okay? And that's going to give us 335.2 newtons, okay? 335.2 newtons. All right, now if you look at part C, at the bottom here, we need a centripetal force acting towards the centre. So the centripetal force acting towards the centre is mv squared on r again, okay? That has to be provided by something. But also we have to deal with the fact that the weight is acting downwards. Okay, so both of those forces have to be the centripetal force plus a force opposite to the weight has to be provided by this normal contact force. So the normal contact force here has to be greater than it was in other positions. So the normal contact force here is equal to mv squared over r plus mg, because the normal contact force is providing a force opposite to the weight, okay, and it's providing the centripetal force as well. So that's going to be 1,120, because that's the centripetal force, we worked that out earlier, plus the weight, and the weight, if you remember, was 784.8 newtons. So that's going to give us 1,904.8 newtons, okay, so 1,904.8 newtons. Now this brings us on to the idea of weightlessness, okay. Basically your weight obviously always stays the same no matter what you're doing in this circle, okay, but at the top you will feel as if you weigh less, because the normal contact force between you and the seat is smaller, okay, than your normal weight. which is 784 newtons. So at the top of the loop, it'll feel like your weight is 335.2 newtons. At the bottom, it'll feel like you are a lot heavier than normal. Okay, 1,904.8 newtons as opposed to this person's normal weight. Okay, so that's what we we talk about when people are flying jets. We talk about the number of G's that they've pulled, so to speak. Okay, because when you can have positive or negative G. When you are at the bottom of a loop, you're going to feel heavier than normal. Okay, and that's going to apply a greater force on your body from the seat. And when you're at the top of the circle, you'll feel less heavy. Okay, and if you're going at just the right speed, actually at the top of the circle, there will be no normal contact force, and your normal contact force will be 0, and it will feel like you're weightless. Okay,